Welcome to the test review for Priority Standard 5, which is reviewing ratios. And there's some wind in the background. Just ignore it if you can. Hopefully you can hear me just okay. So on your paper, make sure your name's on it in your class period so we don't get it mixed up. Remember, the notes you take on this, you can use on the test. So make sure you're taking good notes and you understand how to do the problems. Question 1. Andre paid $13 for 3 books. Diego bought 12 books priced at the same rate. How much did Diego pay for 12 books? Explain your reasoning. So tables are our friends. Looks like my two categories are books and money. So I'm going to put my ratio they give me. So I know there's 3 books for $13. And I want to find out how much 12 books cost. So I'm going to think, how do I get from 3 to 12? I know it's getting bigger, so I'm multiplying. So 3 times 4 is 12. So that means I need to multiply 13 times 4. 4 times 3 is 12. 4 times 1 is 4. And 4 plus 1 is 5. So it would cost $52. And explaining my reasoning could just be showing my table. So I say $52. Make sure you show your work and you don't just have $52 there. Question 2. Select all the ratios that are equivalent to 8 to 6. So I'm thinking 8 to 6. How do I get from 8 to 6 to 4 to 3? I know 8 divided by 2 is 4. And 6 divided by 2 is 3. So since I'm dividing by the same number, A works. 6 to 8, if you flip the numbers, it is not equivalent. That does not work. Okay, so the first number should always be bigger than the second number if the ratio is that way. Next one, 16 to 12. So if I have 8 to 6 and I'm getting to 16 to 12, I know 8 times 2 is 16 and 6 times 2 is 12. So since it's being multiplied by the same number, it is equivalent. Okay, the next one, it looks like they're showing, 8 and 10 have a difference of 2, but it's not changing at the same rate. So it's not equivalent. So don't pick that one. And then the next one we have is 7 to 5. Again, the difference between the two is 2 whole numbers, but ratios are multiplication, like a multiplicative relationship, meaning you can multiply or divide them both by the same number. So this one, it shouldn't be the same ratio in that case. So those two would be the only ones that work. Number 3, Claire travels at a constant speed as shown on the double number line. At this rate, how far does she travel in each of these intervals of time? Explain or show your reasoning. If you get stuck, consider using a table. So, sure, I'm going to use the table just because I like my tables. So we have miles and then hours. I'm going to pick this ratio to put on my table. So I know travel 72 miles in 2 hours. So in 1 hour, I'm going to put 1 here. I know 2 divided by 2 gives me 1, so I'm going to divide 72 by 2. And you may need to do some math. 2 goes into 7 3 times. 2 goes into 12 6 times, so 36. So that means in 1 hour it goes 36 miles. And then for 3 hours, we just times it by 3. 1 times 3 is 3, so I'm going to multiply 36 by 3 to get my equivalent ratio. So 36 times 3. 3 times 6 is 18. 3 times 3 is 9, and 9 plus 1 is 10. So in 3 hours, it travels 108 miles. So tables are our friends. That's a nice way to get there, but you're using the double number line to get a ratio there. Question 4. A train that travels 30 miles in 1/3 of an hour at a constant speed is going faster than a train that travels 20 miles in half an hour at a constant speed. Explain or show why. So let's say I'm going to label this train A and train B. So if I have train A and I have miles and hours, let's say it's going 30 miles in 1/3 of an hour. So in 1 hour, let's see how far it travels in 1 hour. I know 1/3 times 3 gives me 1 hour. So I'm going to multiply 30 by 3. 30 times 3 would give me 90. So it's traveling 90 miles per hour, train A. The other one, let's see, is miles and hours. So we are going 20 miles in a half of an hour. So I'm trying to see in 1 full hour. So I know 1/2 times 2, because there's 2 half an hours in an hour, is 1 hour. So I'm going to do 20 times 2. And 20 times 2 is 40. So this one's going 40 miles an hour. Yeah, so I know this one, train A, is going way faster. And you could say 90 minus 40 is 50. So 50 miles more per hour, which is crazy. So that's how you can show. You can just find out what the speed of each of them is. Okay, moving on to question 5. Solve each of the following. 3 movie tickets cost $36. At this rate, what is the cost per ticket? So tables are our friends. We have tickets and we have money. We know 3 tickets cost $36. So per ticket means 1 ticket. So I'm going to put 1 under here. And I know 3 divided by 3 is 1. So I'm going to divide 36 by 3. And I happen to already know what that is, but you can do long division. 36 divided by 3 to figure it out. 36 divided by 3 is 12. So that means 1 ticket costs $12. And you write money. Make sure you write it in the correct form. Question B. 3 ice cream cones cost $8.25. At this rate, how much do 2 ice cream cones cost? So I'm going to say ice cream and money. So I know 3 ice cream cones cost $8.25. I'm trying to find out how much 2 cost. So one way to do it is first find out how much 1 ice cream cone costs, and then you can times that by 2. So I'm going to do 3 divided by 3 gives me 1. So I'm dividing the money by 3 to find out how much is for 1. So $8.25 divided by 3. 3 goes into 8 2 times. 2 times 3 is 6. 8 minus 6 is 2. Then we bring up the decimal point and we bring down the 2. 3 goes into 22 7 times. 7 times 3 is 21. Subtraction, we get 1. Bring down the 5. 3 goes into 15 5 times. 5 times 3 is 15. So I know for 1 it costs $2.75. So for 2 we're just doubling that or timesing it by 2. So 1 times 2 is 2, so we're just going to do $2.75 times 2. And I'm just going to do some addition. 2.75 plus 2.75. So if you did it correctly, and you can pause and do it on your own, you should get $5.50 for 2 ice cream cones. Find out how much for 1, and then you can find out how much for 2. There's also other strategies as well. Moving on to question 6. A cashier worked an 8-hour day and earned $58. The double number line shows the amount she earned for working different numbers of hours. For each question, explain your reasoning. So it says, how much does the cashier earn per hour? So per hour is per 1 hour. So it doesn't tell us that right here, but you can do a table to find this out, or you could think, 2 divided by 2 gives me 1. So I'm going to divide 14.5 divided by 2. So $14.50 divided by 2. 2 doesn't go into 1, but 2 does go into 14 7 times. 14 minus 14 is 0. Bring up the decimal. Bring down the 5. 2 goes into 5 2 times. 2 times 2 is 4. Subtract and we get 1. Bring down the 0. 2 goes into 10 5 times. Subtract and we get 0. So that means in 1 hour, they earned $7.25, which is minimum wage. So $7.25. How much does the cashier earn if she works 3 hours? If she makes $7.25 in 1 hour, then in 3 hours she's going to make 3 times as much. So I'm going to do $7.25 times 3. I know there's 2 numbers after my decimal, so I'm going to make sure I include that. And now I'm going to ignore the decimal. So 3 times 5 is 15. 3 times 2 is 6, plus 1 is 7. 3. So the iPad shut down on the previous video, so if you didn't quite get the answer on this, hopefully you can do it on your own at this point, but I'll just finish it. So 3 times 2 is 6, plus 1 is 7, and then 3 times 7 is 21. And then we know there's 2 numbers after the decimal, so I start on the right and move it 1 2 times. So for 3 hours, she should make $21.75. moving to question 7. A bag contains 120 marbles. Some are red and the rest are black. There are 19 red marbles for every black marble. How many red marbles are in the bag? So this one's a little bit different than our other ones. So we are going to have red marbles, black marbles, and total marbles for this one. It's a different type of ratio. So I know the ratio is 19 red for every 1 black, and 19 plus 1 would give me 20 total marbles. But I want to see how much it is when there's 120 total marbles, and we're just seeing how many red ones there are. So we have to think, how do we get from 20 total to 120 total? And I know, okay, if I just take away the zeros, I know 2 times 6 is 12. So 20 times 6 would be 120. So then we have to multiply the other parts by 6. 1 times 6 would give me 6 black, and then we multiply 19 times 6. So 19 times 6, 6 times 9 is 54. 6 times 1 is 6, plus 5 is 11. So I know for red marbles, if it was asking me just for red, I would say there's 114 red marbles. Next one. Each of these is a pair of equivalent ratios. For each pair, explain why they are equivalent ratios or draw a representation that shows why they are equivalent. So for this one, I could show 600, I know divided by 10 is 60, and 450 divided by 10 is 45. So I'd say both divided by 10. For this one, I know 45 divided by 15 is 3, or you could say 3 times 15 is 45. So 60 divided by 15 is 4. So divide both by 15. That's how I know. This one is like the other one, but they have an extra 0. So really I could do the same thing as before. So instead of dividing by 15, I'm dividing by 150. I just add a 0 to 15. And same with this. 450 divided by 15. 150 would give me 3. So both divided by 150. So that's how I'm explaining it. You could explain it more or less, but that's one way to do it. Question 9. A grocery store sells bags of oranges in 2 different sizes. 3-pound bags of oranges cost $4 and an 8-pound bag cost $9. Which oranges cost less per pound? So per pound. Per pound means 1 pound. So in other words, we take the money and we divide it by the number of pounds, and that tells us how much per pound or for 1 pound. So in this case, we're going to do 4 divided by 3. And then this case, we're doing 9 divided by 8. So let's start with 4 divided by 3. 3 goes into 4 one time. 1 times 3 is 3. 4 minus 3 is 1. Then I'm going to add a 0.0. I'm going to bring up the decimal and bring down the 0. 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. So I'm going to add another 0. And I see that there's a pattern. 3 goes into 10 3 times again. 3 times 3 is 9. 10 minus 9 is 1. So this pattern is going to keep going, the 3s. So I could really say this one's $1.33 per pound if I'm rounding it. Now for 9 divided by 8. 8 goes into 9 one time. 1 times 8 is 8. 9 minus 8 is 1. And I'm going to add a 0.0, bring down the 0, bring up the decimal. 8 goes into 10 one time. 1 times 8 is 8. 10 minus 8 is 2. I'm going to add a 0, bring down the 0. 8 goes into 20 2 times. 2 times 8 is 16. So I really could stop here because I know it's going to be $1.12, or I might round up if I needed to for the next one. And the other one's $1.33. So that one, this costs more, the 3-pound one. So I know. But I'll just go down and just make sure. 20 minus 16 is 4, so I add a 0, bring it down. 8 goes into 45 times. So if I was rounding it, I would use this 5 to round to the 2 to a 3. So the 8-pound bag, or say 8-pounder, costs, and you have to write it in money ways, so in money terms. So $1 and 13 cents would be it rounded. Question 10. A sports drink recipe calls for 5/3 tablespoons of powdered drink mix for every 12 ounces of water. So I'm going to set up a table. So I'm going to say so powder, and then water. So we have 5/3 and 12. It says, how many batches can you make with 5 tablespoons of drink mix and 36 ounces of water? So this one's going to be easy. You could just look at one part of the ratio. So I know 12 times 3 gives me 36. So that means I'm making 3 batches because I'm multiplying one of them by 3. And then you could also say, 5/3 times 3 is 5. So both ways work. Okay, we're almost there. We're going to finish this table. Lynn rode her bike 2 miles in 8 minutes. Complete the table for different answers. So 2, I know 2 divided by 2 gives me 1. So I'm going to divide 8 by 2. 8 divided by 2 is 4. Now I have to think 4 divided by 4 gives me 1. So I'm going to divide 1 by 4. So this is where people mess up. 1 divided by 4, don't overthink it, is 1 over 4, 1/4. You can just write it as 1/4. Or you could write it as 0.25 if you know what it is as a decimal. But it goes 1/4 of a mile. Then question 12, select all the true statements. So we have 1, 2, 3, 4, 5, 6 smiley faces, 2 triangles, 4 squares, but it might ask for equivalent ratios. So we'll just pay attention. The ratio of triangles to squares. So triangles first is 2 and squares is second, 4. Yep, that works. B, the ratio of squares to smiley faces. So squares should go first, but it's giving us the number of smiley faces first, so that doesn't work. C, the ratio of smiley faces. So smiley faces should be 6, triangles should be 2. But smiley faces say 6 and triangles say 4, so that does not work. D, there are 2 squares for every triangle. So when there's 2 squares for every 1 triangle, yes, that's if I cut the rest or the ratio in half or divide it by 2. E, there are 2 triangles for every smiley face. So 2 triangles for every 1 smiley face? No, there's 6 smiley faces, so nope. And then F, there are 3 smiley faces for every triangle. So I see it right here. There's 3 smiley faces for 1 triangle, 3 smiley faces for 1 triangle. So this one does work. So thanks for watching the video.